Okay. How's the voice? Voice level okay? Awesome. Thanks, Bradley. We'll start now. There's not a lot in this session today. I think we'll probably be finished in about 30 minutes. It's not a long session. It's about wireless, but you know the way that I talk, maybe I might extend it just by talking too much. But this is about wireless, and this is a good start for you because you will have an assessment on wireless, right? You're gonna have one. So this is a good little welcome, Kevin. So first of all, there's a couple of different types of, before we get into wireless, just want to double check something. I'm not sure why I've got that out of order. There must have been a reason. I should have fixed this before I started. All right, just ignore this, but I am going to write on it. Just ignore this for now. So let's look at what makes up a wireless local area, a WLAN, wireless LAN. And I might do a bit of show and tell as well. In fact, I will. I'm going to show you some some parts to make this happen in a Cisco environment. I'll be back really quickly. Okay, so I've got some physical devices that I want to show you that make up a wireless network. I mean, obviously, you've probably all seen your wireless router at home that gives you your internet access, you know, to your mobile device, or a laptop. That's a wireless LAN too. However, in a corporate environment, it's a bit more complicated than that. Well, a lot more complicated actually. In a wireless environment and in a business, you're going to do something like this. Here's your wall, and you'll have a little wireless device, wireless and access point that will transmit your signals. And as your mobile device is walking, you can hop onto different wireless access points, right? Then what happens is these are cabled, physical cables at the back to, if we look at, this is through the top of the ceiling, into a closet room, okay, that's connected to a switch. And a lot of these switches have got power over Ethernet switches, okay? So what that means is that these switches are giving off power. So we don't need these to even have electricity on it. However, that's not it. That's not the end of that story. We need a wireless LAN controller as well. A wireless LAN controller. And this is the device that's connected to the switch as well, that centrally configures this wireless infrastructure. So instead of going to each one of these access points and configuring them via telnet, not telnet, SSH, or some sort of web-based browser. We're going to configure this through our wireless LAN controller. So let me show you what this all looks like. These are really old devices that I've got. I know that who's watching the recording after this probably won't see it, but that's what a wireless router, so wireless access point looks like. And at the back, you'll see some, there's an Ethernet port. There is a power cable. However, you can run this over power over Ethernet. So you get power from the switch. The switch gives this electric supply and gives it data as well. And that sits on a ceiling and transmits. This is a very old one. It's like maybe 15, 20 years old. Still works, by the way. I run some Cisco CCNA and CCNP labs off this stuff. Okay. Then just that connects to a switch. Okay, a Cisco switch, which looks like something like this, right? So that's a Cisco switch. There's 48 ports, and some of them, not all of them. Just double checking. You know what? I don't even know. I'm not sure. I don't even know if they have power over Ethernet, so it's possible. But these access points, wireless access points, connect here to these ports. Finally, it's a very heavy machine, by the way. But finally, and these are very old devices. They're still, the newer ones look a bit better, and some of them are software-based too, like the Cisco's Meraki is a cloud-based technology. But that is the wireless LAN controller, and you've got ports there as well that connect. This connects to the switch, and we'll use these many ports to connect to maybe different VLANs. We'll do so many different configurations. But that's a wireless LAN controller, and that one can control. That one can maybe take care of around about 50 access points. Okay. Now, nowadays, most of this is done through. Well, not most of them. Probably a lot is done through a cloud-based, software-based wireless LAN controller. So they're physical. They're still there, but not as much as they were before. So let's have a look at a couple of these concepts. So we'll talk about the basic server set first. Okay, the basic service set. And basically what the basic server set is, it's sort of like a it's sort of like a okay, if I draw it, might make it a little bit easier to identify. It's kind of like, in a way, kind of like a switch. Okay, so you have all your devices in this area, and these are all connecting to a wireless access point, giving out wireless signals. So really, in effect, this is a close group of mobile devices that forms around this access point. So to participate in this, the access point actually has to advertise to around the network to say, hey, I'm a wireless access point. So long as you can find me and log in and authenticate yourself, you can communicate with me, and I will get all your data and I'll send it to a switch. And you can communicate with other devices on this network. Okay, so that's a basic server set. Now, to make this even wider, you can get another access point with another basic server set connected to the same switch, and we have our devices connecting to the access point. And then guess what happens? That becomes an extended server set. Extended service set, which is here. And what that means is that I can walk anywhere with my mobile device and I can access these access points and still be on the same network. Okay. Now, for me to connect to these network, I need to know what the SSID is. And the SSID is the name that advertises, like when you go to, say, like Starbucks, the Starbucks network, or the McDonald's network, or Harry's network. Okay, that's the name that we are actually linking to. Okay, now this wireless distribution system, this is what I was mentioning before. This is our wireless LAN controller that distributes all of this technology together. Okay. Now, say, for example, I have a guest network and I have staff network. I can create separate VLANs in my network, and I can create two different SSIDs. I could create a guest network, guest internet, and say staff internet. So we log on to either one that we're entitled to. Once we access our the SSID that belongs to us, in our switch we have our different VLANs. So we'll have a VLAN for staff, VLAN for guest, and we can separate it. So if a hacker comes in and logs in through the guest network, that it cannot interfere with the staff network because they're separated by a VLAN. Okay, now let's just really quickly talk about a mesh network. Let me show you. I'll go to JB Hi-Fi store because this is the only way. This is the only place I know where to get this device for a mesh network. I'm going to show you a couple here. Oops. So these devices here, for example, the Google Nest Wi-Fi, pretty expensive actually. But what happens is that you've got these three, they're kind of like access points, but one of them will be connected to your broadband. Maybe it's your the one that Telstra gave you or Aussie Broadband gave you. We'll connect it up to your NBN device. NBN. And what happens is you put this one in another room. You put it somewhere else, okay? And you put this one somewhere else, and you put that one next to your NBN. And why you do that is this. Say, for example, you have a really big house, okay? And you've got two levels. Okay, you've got the door there, you've got the windows. And you've got up here, you put a wireless router there. You put this is your NBN coming here. And you might have one in your garage. You might have a garage there. Now, if you don't have a mesh network, you're going to struggle getting getting wireless if you're up on the second level, or if you're in your garage. But because these devices, these wireless routers, can connects to that one, and that one connects to there, and they connect to each other to form a mesh network. So that means you get much better coverage. Now, with a double-story house, you might need more than 3, and it depends. In smaller houses, 3 is perfect. So that's how a mesh network works in a wireless network. Okay. Now, just really quickly with the hotspot, this is a nice little tool if you want to if you've got you've got your mobile phone and you want to use your friends, you can use their hotspot. So that's their mobile phone, and this is you're borrowing their hotspot. Okay, nothing. It's really easy to understand that part. So you don't really need to memorize all this stuff, right? These protocols, the architecture. But basically, it used to be hard to memorize this stuff. These are standards, right? These are IEEE standards. When the first wireless came out, like in the late 90s, it ran on the 5 gigahertz spectrum, and it ran up to 54 megabits per second. Whenever you see something like that, always remember it is up to. Okay, I'm going to show you something. I've just installed in my home. I've got a couple of Wi-Fi 6. I've got 3 access points in my home, which is Wi-Fi 5, and I'll double check, but I think they're saying that I can get up to 1 gigabit per second. 1 gig per second. I've installed Wi-Fi 6, and I don't know how much. I'm not sure. I'm going to double check, but I think I hear up to 10 gigabits per second. Now I've tested this absolutely thoroughly in my house. I've got wireless right upstairs, right above my room. Let me show you. It's right up there. I'm not sure if you can see it. It's right on top of my room, so on top of the roof. The maximum I can get out of it, I've tested, I've done everything I can. Right above me, I might be able to get 300 megabits per second. On Wi-Fi 6, it's supposed to be gigabits. It's supposed to be a lot, but I can only get 350 megabits per second. And I've done everything I can. Like and by the way, I'm happy with that. That's pretty good. I mean, that's really good. But so these are all just theoretical download speeds. They're just theoretical limits. Someone has tested it in a lab environment and got that up to that. But anyway, I'll talk a little bit about the spectrums shortly. But that was the first standard. Okay, and they call it Wi-Fi 1. But Wi-Fi 2 was released first because that just took too long to release, and this one is quicker. Now, really, really quickly, okay, it's something really important to know, especially for cybersecurity. If it's on the 2.4 gigahertz, you get a bigger range, okay? On the 5 gigahertz spectrum, it's lower range, but faster. So the reason I'm talking about this being a security concern is even though you might get a bigger range on 2.4 and a bit of a slower speed, do we want it to be extended further distances? So consider this: if you're a business, do you really want your Wi-Fi going outside in the street? So in my home, the way that I've set my wireless, the way I've angled it, the way where I've put it is I'm trying, I don't want it to go outside my house. I'm trying to restrict it. So when I go to my car, I actually I can't access my Wi-Fi. And when I'm in the backyard, I can't access my Wi-Fi. Some places I can here and there. I actually don't want my Wi-Fi to be broadcasted to my neighbors. And I do that on purpose. So I will never use 2.4 under any circumstances. There's just no point. It's slower. And the way that I've placed my wireless around the house, I'm getting good speeds everywhere. I've got 5 access points throughout the house, so I'm covered. There are some dead spots in my home, and something for you to consider as well. Thick walls, and also around microwaves. Microwaves operate on the same spectrum, okay, as Wi-Fi, very, very similar. Things like baby monitors. We used to have, the cordless phones. No one uses them anymore, but they used to interfere with Wi-Fi as well. But anyway, these are the Wi-Fis. Now, when we say Wi-Fi 1, 2, and 3, 4, they were not called that at the time. That was, the names were given retrospectively. Later on, some people decided to give it names. So now Wi-Fi 7, and now Wi-Fi. I was at Cisco Live, and Cisco has just released Wi-Fi 7, and also Ubiquiti has Wi-Fi 7. Let me just show you what that looks like. That pretty much is going to be a game changer. The only problem is we need devices that can support that. So if I go to Unify, what is it, Wi-Fi 7, they just released this one now. Look at that. So basically, this is the product range for Wi-Fi 7, and they're marketing to businesses that have, please check this out. This is a good learning tool. If you want to learn about something, can I tell you something? If you want to learn about technology, do this. This is the best place to learn about technology. JB Hi-Fi or Harvey Norman, it doesn't matter. JB Hi-Fi. You go to JB Hi-Fi and you go and grab one of those brochures they have, and you read through it. That's the best way to learn about technology. Learn about Copilot. I didn't even know Copilot was out until I was at JB Hi-Fi. Learn about computers, So you just you get one of these catalogs, and you actually go through it, and that's how I first learned about wireless mesh. I thought, wow, this is cool. How come I didn't know about this? So you go through this, and you have shoulder massage. Ooh, okay, I like the look of that. I might pick one up because my shoulder's a bit sore lately. So, but anyway, so I go to Unify, which is a competitor to Cisco. It's a much cheaper brand. It's what I use at home because I can't afford $150,000 worth of Cisco equipment. Over the last 5 or 6 years, I might have spent about a couple of thousand wiring my home. I did most of it myself, but I needed some help. But it's over 5 or 6 years. It cost me a lot of money, but it's really powerful. This is Wi-Fi 7, and they're saying that you can get up to just that speed that you could see on that mobile phone. That's 2 megabits per second. Man, if I get to look at that, see that download that's about 2,400 megabytes per second. Well, no way that's going to happen, right? But they're claiming that. So, but that's for big businesses, and this is for probably like for stadiums. Okay. So do look at these websites. This will enhance your knowledge. It will get you excited and interested. It will get you really hooked into this stuff. Wi-Fi is an amazing technology, and between you and me, there's good money in this if you want to make money. By the way, I don't have my headphones on, so if anyone wants to say anything, if you can just text first, and I'll put my headphones on. The reason I don't have my headphones on is just really hot. It's 36 or something, so I'm trying to ventilate a bit. If we look at if we go over to Cisco has just released their Wi-Fi 7, and I saw that at Melbourne the Cisco Live conference. It's really impressive. That's what they look like. This website's not as fancy as the Ubiquity because they don't need to. They've got, this is a business. Okay, they're looking for business. They're dealing with medium to large enterprises, whereas Ubiquity are looking for smaller to medium-sized organized businesses. So actually, Cisco's this discussion on Windows 7 on their webpage is actually pretty poor, really bad. They need to talk to their marketing team. Maybe I can go somewhere different. Yeah, that's a bit better, I guess. Yeah, it's really boring. No, they don't really care about marketing because this is for large businesses anyway. But that's pretty cool, the Ubiquity one. And that's an example of a cloud-based site manager. So this is where you can put into walls, put them on the ceiling. If you want to go outside, you can put this wireless outside on a pole and get access if you're outside as well. I've seen a couple of these at festivals and at shows. And this one is mega capacity. That's for the stadiums, the football or basketball stadiums. You can do a point-to-point, so like a bridge over like maybe 1 kilometer or 2 kilometers, really fast. So that's cool. I like wireless is interesting. And it's all based on the 802.11 protocol, which is a series of wireless communication developed by the IEEE standard. These are all like what you really should need to know about this is they're all kind of based on various technologies and speeds and also encryption as well. I'm going to show you a couple of diagrams shortly regarding the difference between 2.4 gigahertz and 5 gigahertz and how they operate on a different spectrum. So let me go get some, I'm going to get an image here, image map, not image map, something from Google. 2.4 gigahertz Wi-Fi. Now, if you have to run 2.5 gigahertz Wi-Fi, I'm going to just show you really quickly what that kind of looks like. So these are the channels that are available on the 2.4 gigahertz spectrum. You can only use 3 channels because these other frequencies interfere with each other. So you can use the 1 channel, 6, and 11. So this is what you do. Okay, you go and get a protocol. You get a wireless Wi-Fi analyzer. Especially if you're living in an apartment building, and most routers should do this automatically. But if you notice that everyone is using this one most, and no one's using the 11, change your settings to only use the channel 11. You will start seeing an increase in performance straight away. So do that today. You can use your mobile phones. If you've got an Apple or an iPhone, you can download free Wi-Fi analyzers. If you look at the 5 gigahertz, we've got a lot more variety. 5 gigahertz Wi-Fi, and we've got a much bigger range of channels. That's not very clear, is it? I'm trying to get a clearer one. Yeah, I think this might be a bit better. But remember, as we use 5 gigahertz and it's faster and we have a higher range, higher speeds, it's, you know, we have to manage this a bit better. So now we've got 1, 2, 3, 4 channels, 5, 6, 7, 8, 9, 10, 11, 12, 13. And with the 6 gigahertz coming out, 6 gigahertz, there'll be even more channels. It just means that if you're in an apartment building and you can spread these channels out a little bit evenly. Sometimes you'll see a channel that no one's using. Go ahead and use that, and you get that channel all to yourself. That means there's less interference, and you'll get better performance, less packets that are dropped, and more faster speed too. Outstanding. Okay, now but here's a problem with Wi-Fi, and this has always been an issue. What are we doing with Wi-Fi here? Let me give you a scenario. We've got a switch. We have a computer there. It's physically connected to the switch. What does a hacker have to do to get that communication? They have to physically walk in here and pull that cable out and put it in their laptop or connect to a port. This is what a hacker actually has to do. It's really difficult to pull off. But if you have Wi-Fi, you're giving hackers a free access to be able to get access to our network. We're exposing our network. We're giving it to them. We're giving them an opportunity to be able to at least even try to get into our network. So there is, we do have some security features, but a lot of, and you guys, I want you to do this today at home. I want you to go to your wireless router, okay? Connect via your Cat6 cables, connect to your router, and access the access the administration portion, and I'll show you really quickly what that looks like. And make sure that you change the default username and password of your wireless router. You know why? Because there's a website, you might have heard of this, called Shodan. And on Shodan, it crawls out to the internet and it tries to find wireless devices and wired devices that has these default credentials. This is a legitimate website. Okay, they're trying. I mean, these are, you're basically by having your default credentials, you're advertising to people to come in and hack your devices. So you need to harden your wireless devices and all devices too, even your IoT, and change the configuration so that it's not the default. See all these, there's a lot of exposed servers that we can, pretty much go into. See, look at this, you got top operating system. These ones have got default configurations. Look at these top products. These are routers. These are routers that people can go into. Now, sometimes it works, sometimes it doesn't. It's annoying, it's hit and miss. Please I need to log in. So I need some login credentials. I'm a bit poor at the moment. I have my I have to pay my electricity bill for this month. But you can actually hack into these systems. It's crazy. But I'm going to show you really quickly on how to do that. There's some emulators for D-Link, for example. So you can practice your software skills on these devices here. I haven't been here for a while, so I'm not sure how this is going to work out for us, but we'll try. We'll we'll open that, and that'll show us that'll give us an emulator. It's not real. It's just some software that we can log into a wireless router. I'll just Google it. You'll find it. So now I'm in a administration area. You can have a look at Wi-Fi. You can see basic settings. So just Google it, D-Link emulator, and you'll be able to get this. Just Google D-Link. There's other ones too. And I can change. This is my network name, the SID. I can call it Harry's SID, and I can adjust the channels. What I'm looking for here is security settings. So where is it? Where can we find it? Initial configuration? No, not quite yet. Maybe system? No. Advanced? Basic settings? We'll go to basic settings. Security settings, yep. You can change this to the, so these are encryption. If you use Open or WPA, you're basically advertising, you're saying to everyone, hack my system. You want to go at least to WPA2. That's the encryption over the wireless. You should go for YPA3 if you can. But what I'm looking for, and I can't find it, is changing this administration cost. Now, by the way, before I look into this, you have the ability to hide the SSID. Now, there's a theory that if you hide your SID from the public, that they won't be able to see your network and they can't hack into it. Let me tell you, hackers they've got on a Wi-Fi analyzer. They'll get it in 2 seconds. You're only annoying yourself by doing this because you have to type in your SID instead of it coming up on the list of networks that will appear. So don't bother with that, in my opinion. In my opinion, don't bother with that. But there are a lot of opinions out there that say no, hide it. That'll make it harder for people. But I don't know. I don't believe that's going to make any difference. I want to change the admin and password. Anyway, I might give this a miss, but download this, play around with it, or go to your own devices and see if you can set that up on your own machines. Devices. Basic settings, print server, advanced firewall. Not really. I don't know. I thought it would be here. Configuration. Go away. Factory, restore, backup. Oh, here we go. There we go. So it doesn't look like it will let me change the username, but you definitely should choose a new password. And this is why. Hackers can do a quick search. Hackers would say, what is the default username and password for D-Link router? And it just gives people a real password list. There's a website that actually shows you the password list right there. Some of them don't even have passwords on them. So check your wireless routers and do it today and change them. That's a part of device hardening for wireless. This is a huge issue. Exactly, Brad. On my Telstra's NBN device, it's printed on it. I'm like, what? Try to do a site survey if you can. This isn't a business. You probably don't have time to do this at home. But what an evil twin or a rogue wireless device is, and I've actually done this with permission. Okay, never ever do this without permission. Don't go to Starbucks and do what I'm just about to tell you now. Okay, you can get yourself a laptop, install Kali Linux, put a Wi-Fi and get a, it's got Wi-Fi already, but you can do this today if you had the skills. It's not that hard. It's difficult, but you need your Linux skills, you need your hacking skills, you need some hacking abilities, but it's not hard to do. You don't need to spend millions of dollars on this. Excuse me. but this is how it works. So you're at Starbucks. Those people who are still using Starbucks, I think there's a bit of a boycott. People are not buying stuff from Starbucks anymore. To be honest, the coffee's crap there anyway. I make my own coffee, so I'm very fussy. But this is their internet. That's the internet. And this is their wireless router. And that's broadcasting signals. So you have your mobile phone device that's hooked up to that. You might get I don't know, I haven't been to Starbucks in ages, but I think they used to print the password on the docket or the receipt, or could be printed on the tables or Q code. I can't remember. It's been ages since I've been there, so I don't know. But anyway, what I haven't done this at Starbucks, but I've done this in a lab environment. What I did is I hooked up a Kali Linux machine, laptop, Kali Linux. So this one had a SID and it had Starbucks. That's the name of it. I'm just giving you an example. I haven't done this, Starbucks, but I've done this elsewhere. So what I would do is I would create another SID and I would do something like Starbucks free or Starbucks premium. I guarantee you, if you put Starbucks premium, everyone's going to try and get onto that. So this mobile phone device will see that SID, will connect to it, and it performs an on-path attack or a man in the middle. Politically correct, the word is on-path, but people still use that as man in the middle. So the mobile device connects to this Kali Linux machine, connects there, and the Kali Linux machine sends it to the router, and it goes, they're getting traffic. You're going onto Facebook, and check this out, listen to this. You go to Commonwealth Bank or Westpac websites, you put your customer number and your password into that, and guess who's getting that? Guess who's recording that? This laptop here is getting your credentials, storing it, and saving it into a file. It is that easy. I'm not joking, right? It is that easy. Even though it's done through HTTPS, that's supposed to be encrypted with TLS certificates. What this Kali Linux does is it negotiates with the web browser here, and it removes that the need to have a certificate, and then it puts it back on as it sends it out that way. That's how it can view your traffic unencrypted. So next time you're at Starbucks or McDonald's or at the airport or in another country, if you have to use public Wi-Fi, if you have to, right, use a VPN. Because the VPN will encrypt it from there, these packets, through these rogue devices, and all the way through the internet. Use a VPN. That's if you have to use public. My advice is don't use it. Don't use public. Don't go to Starbucks. 20 or 30 gig of downloads, I think it's like $20 at Kogan or something. That's plenty if you're out. Most of the times we're hooked up to business or home networks, right? That's plenty. You don't need to get public Wi-Fi, but if you have to, don't use it without VPN. Okay, VPN will defeat this attack. Okay, so that's another way. Businesses will use an AAA server or like Radius or TACAX. Basically what that is you might have an Active Directory server, you'll have a AAA server, and your laptop will need to authenticate here, and this AAA server will ask Active Directory for permission to grant access to that laptop to have access to Wi-Fi, and it says yes or no. You can have a captive portal, so that's like when you're on an airplane. I know last time I was on Virgin, they had Wi-Fi, not free, unless you're in business class. Sometimes I get some upgrades. I look after myself now and then. I've got a lot of points, so I can because I used to travel a lot. So now and then I spoil myself and get business and get free internet. But you go to this web page. Yep. You have to sign in. You have to accept, or you have to put like your seat number or your membership number in there. So that page anyone can get access to, even a hacker, right? But then you've got to put some credentials in there. Then you access. Use 5G if you can. Dead spots, microwaves, heavy metal objects, anything that reflects or bounces waves. Consider omni and directional transmission. Omni means, so this is your access point. Omni is all directions, up and down, because if you're in a multiple level story. And a directional is, say, if you want to focus the beams, so like that way, you want to focus it that way. That's a directional. This is really quick and really quick and fundamental stuff. If we have too many users, add an AP into the system. Add another AP. All right. Any questions? So while you're thinking of your questions, I just want to show you why this is relevant for you now, because and you've got some time, by the way. You've got plenty of time. Okay. Because assignment 3 is about wireless security standards. And you're going to be talking about some of these things that I've briefly mentioned today. You're going to talk about the historical background of standards, and I went really quickly over. I didn't spend much time on it. And you look at the function and the security aspects. You're going to talk about WPA. You're going to talk about WEP. You're going to say that how bad WEP is. You'll mention that in your assignment, and you'll say that, and you're going to mention WPA. 3 is the best, but minimum is WPA2. And it's not a really tough assignment. It's actually pretty easy, pretty cruisy. It just means you've got to do a little bit of work for that. You've got a PowerPoint presentation you need to submit as well. But yeah, that's why we're talking about this a little bit early. It gives you a bit of time for preparation. But other than that, any questions? My intention was only to do this for about half an hour, but I get excited. I like talking about Wi-Fi. I don't know, something about Wi-Fi that's magical. When I first had Wi-Fi around about 2000 or something like that, it was amazing. If you think AI was exciting, or when Wi-Fi came out, it was like, no. When I set it up, I couldn't believe it. It was like, look, Mum, no hands. No cables anymore. Really cool. Kevin's asking, with WAPs, wireless access points, is the bandwidth shared between clients? Okay. Good question. So you've got your wireless access point here. And you're getting Wi-Fi omnidirectionals all over the place. So what's happening here? You've got your wireless devices and mobile devices. You've got a laptop. And they're taking turns. They take turns. Can't write for some reason. Well, I've never been able to write, but today especially, it's too hot. So these devices actually takes turns with the bandwidth. So this mobile device says, well, it's my turn now, and it will transmit. Then the computer says, well, now it's my turn. Then it transmits and downloads. So they share the airspace with the bandwidth. And then from when the data reaches, and that converts from wireless signals to digital signatures through Ethernet, then it's just like wired. It shares it like a wire. So it does share, and they get sort of like a time. This is called a collision domain CDSA, collision avoidance, CDM. You know what? I've forgotten it. Hang on. You know how many times I've done my exams where this is a classical question. CSMA. Yeah. Sorry, mind blank. So this is carrier sense, multiple access. When you ever see multiple access, Kevin, when you see multiple access, you are sharing the bandwidth. Absolutely. And the more devices you have on the network, the more they compete for that airwave, for that shared bandwidth. So yes, absolutely they do. But if you have more than one access points, that's less, that they have to share with. It reminds me, I don't know about you kids, but we had 7 kids in our family, and when it was fish and chip night, the more kids there were, the less fish and chips there was to go around. And if you got like $5 worth of chips, the less chips we had. So basically, it's $5 worth of chips here. You have more kids coming over, you buy another $5 worth of chips, and you get to share more of them. So really good question. So the more devices, the more users, higher traffic, the more competition for the bandwidth, the lower performance, more collisions, more packet loss. Not good. But there's solutions around that. Good question. Any more awesome questions? Anything else? All right. You all have an amazing weekend. If anyone needs anything, reach out to me. I'll be able to. I've got 6 weeks off work. Well, technically, it's not. I should be at work, but I'm at home for the 5 weeks. So I'm more than happy to help anyone who has any questions. But other than that, I'm going to call it a night. Everyone have an amazing night and have an amazing weekend, and take care. Try to stay cool. It's really hot at the moment. So good night, everyone.